Okay, so here it has been told that assume that each born child is equally likely to be a boy or a girl. If a family has two children, what is the conditional probability that both are girls, given that the youngest is a girl or at least one is a girl? So if a family has two children and each born child is equally likely to be a boy or girl, then this will be called as a random experiment. Since here every outcome is equally likely to happen. So then the sample space of this experiment will be that either both are girls means the first child is a girl and the second child is a girl, or I can have that the first child is girl, second child is boy, and I can say that the first child is boy and the second child is girl, and we can say that the first child is boy and the second child is also a boy. So there are four possible outcomes in the sample space of this given experiment. Then here it is asked, what is the conditional probability that both are girls? What is the conditional probability that both are girls, given that the youngest is a girl? Given that the youngest is a girl. So mm, here we can first define some events that, let's say, the event A is defined as the event that both are girls, event that both are girls. So therefore, the event A can be written as G1, G2, G1, comma G2. And let's say B is the event that the youngest is a girl. The youngest is a girl. So then B will be um, G1, G2, and G1, B2. So there are two favorable outcomes in this event. And the event C can be defined as that at least one child is a girl. At least one child is a girl. So therefore the event C can have the outcomes, that is G1, G2, and G1, B2, and B1, G2, B1, G2. Okay. So here are three favorable outcomes in the event C. So now here it is asked, what is the conditional probability that both are girls, given that the youngest is a girl? Means P of A given B, that we have to find. So that would be P of A intersection B divided by P of B. So here, from here, you can see that if we do A intersection B, then it is G1, G2 only. It means A intersection B is the common elements in these two sets. Okay, so therefore P of A intersection B, that would be obviously the number of elements in A intersection B divided by the number of elements in the sample space, divided by P of B is the number of elements in the event B divided by the number of elements in the sample space. So these two would cancel. So then the number of elements in A intersection B, that is 1, so it will be 1 by 4. And this will be it's, so here suppose we don't cancel this n of S. So this will be 1 by 4. Since here you can see the number of elements in the sample space, that is 4. So then the number of elements in B, that is 2. So 2 by 4. So that will be 1 by 2. And then in the second part, it is told P of the probability that both are girls, given that the at least one is a girl. It means we have to find P of A and P of A given C. So that would be P of A intersection C divided by P of C. So this will be the probability of A intersection C. So we now have to find A intersection C. That will be also G1, comma G2, means G1, G2. So only one element. So this would be 1 by 4 divided by the probability of the event C. So that would be, so number of elements in the event C is 3. So this would be 3 by 4. So the answer is 1 by 3. So these two are the final answers. Thank you.